Okay, so in the last video we'd set up this matrix for this system of as many as problem about the chips and the drinks, and I had noted, excuse me, that I had written my equation a little bit differently. Let me just explain that a bit more, why it's okay to do and why either one would work. Because if I have the equation negative d plus 5c equals 0, and I divide this entire equation by negative 1 or multiply it by negative 1, if I get everything gets a negative 1, multiplied, then the left-hand side would become positive d minus 5c, and the right-hand side would be negative 1 times 0, which is still 0. So these are the same equation. It doesn't matter. Okay? So however you set it up, as long as you set it up like this or like this, it's fine. All right, I just chose this method because that felt better to me. Anyway, so my matrix would actually be 1, 3, 1, negative 5 instead of this matrix. But like I said, either one's okay. But I'm going to use this one. Let me pull up my calculator and enter my matrices, and then we'll go for it. 2 by 2 matrix, 1, 3, 1, and negative 5. That's my A matrix. And my B matrix is 48 and 0. Okay. And then we do A inverse times matrix B. And there's our solution, 30 and 6. So 30 drinks and 6 bags of chips, which you see is the same value that you get if you use this matrix or you use the matrix that I used, which was 1, 3, 1, negative 5. That's interesting. So there you go. 30 drinks and 6 bags of chips. There is another example. I'm going to skip this next example, but I encourage you to look at this. It is in the notes. I'm just going to skip it for interest of time, but it's basically the same problem, just with more realistic costs. So take a look at this problem. It'll give you more practice doing these, and this will be helpful in the homework. But I want to go ahead to a chemical equation problem. If I think that these do not appear until 4.2b on the homework, I believe. But yeah, so let's take a look. So we have a chemical reaction, and somehow we're going to use matrices maybe for this to balance this chemical equation. So first of all, what does any of this mean? We have hydrogen gas reacting with oxygen gas to form water. So it's not quite as straightforward as the previous examples as far as what is the question. What does it mean to balance the chemical equation? Well, essentially what it means is we want to know how many molecules of hydrogen plus how many molecules of oxygen will form a given amount of water. Okay, and so we have to write an equation, as you see right here. In fact, before I do that, let me can I give you a little more context? Let's suppose we want to make 1 molecule of water. Okay, so I'm going to think of this as like my target. So I want to know how many molecules of hydrogen do I need and how many molecules of oxygen do I need to make 1 molecule of water. So let me just write that out in words. Number of molecules of H2 plus the number of molecules of O2 to make 1 molecule of H2O. Okay, so this helps me to think about what my unknowns are going to be. So specifically, my unknowns, let's say x can be the number, it can be this, it's the number of, it's supposed to say of number of molecules of H2, and let's let y be the number of molecules of O2. Okay, and let me insert another slide in here to write on. Okay, so what I have at this point is I have x molecules of H2 plus y molecules of O2 gives me 1 molecule of H2O. Okay, and then we're going to figure out what x and y are. So what equations can we write from this? So this is going to be a little bit of a special skill, but what we're going to do is we're actually going to think about the atoms. Or the we're going to write element equations. So in other words, I'm going to write an equation that I'm going to look at each element in my reaction. So I have 3 elements. I have hydrogen, I have oxygen, and I have 2 elements. I'm sorry. I have hydrogen and oxygen. So I'm going to write a pure hydrogen equation. And it's the same thing as like in the mixture problems when we wrote like a pure methanol equation. The pure hydrogen equation is going to say however much hydrogen from the first thing from however much hydrogen from the second thing has got to equal the number of hydrogen atoms in the third thing. So when I say how much hydrogen, I mean number of hydrogen atoms. So number of hydrogen atoms. So how many hydrogen atoms are in this first reactant? So we have 2 hydrogen atoms per H2 molecule times X molecules. So that would be 2X. And then for YO2, how many hydrogens? Well, we have 0 hydrogens for Y molecules of O2 because there are no hydrogens in the O2. So it's 2X plus 0Y. And that's got to equal the number of hydrogen atoms that are in 1 molecule of H2O. And 1 molecule of H2O has 2 hydrogens in it. Okay? So there's an equation. And then similarly, we can write a pure oxygen equation. So we think of the same thing. How many oxygens are contributed by H2? Well, 0 oxygen atoms times X molecules. And then for this one, we have 2 oxygen atoms for Y molecules. And then together those need to give me, H2O has one oxygen atom. So essentially what I'm doing is I'm saying there's sort of like a 1 there, and it's like with this 1 times this 1. Okay, so I have a 2x2 system. Now you probably could just balance this equation just by guessing, but we can also use this matrix system. So now my matrix, my A matrix would be 2, 0, 0, 2. And then my unknown would be x, y. And then my B matrix would be 2, 1. And so now I can use a matrice and do 2, 0, 0, 2 inverse times 2, 1. And that'll be matrix A and B, and we can solve it in the matrix method. Okay. So if you want some further exposition about this, just take a moment and read through the notes right here. It's essentially the same thing as what I was saying. And we end up with this system. Okay, actually, so let's pause here for a second. So there's our system. I'm actually going to do this one in the calculator because there's another complication here that's going to pop up that we need to address. So let's do the computation. Matrix A is 2, 0, 0, 2. Matrix B is 2, 1. So 2 by 1, that is 2, 1 in its entries. Okay. And then we're going to multiply A inverse times B. And there's our solution. So we get x equals 1, we bring that back, and y equals 0.5. So this is great, except there is a problem. So let me explain the problem. So x equals 1 means we have 1 molecule of H2, and 0.5 means 0.5 a molecule of O2. So that's fine, except that you can't have 0.5 of a molecule. Okay, so you can't have, I mean, that doesn't exist. You can't have half a molecule. You have to have a whole molecule. So what do we do? Well, what we're going to do is basically scale scale the balanced equation up, because the equation is balanced. It just chemically couldn't happen. Mathematically, it's balanced. So here, let me remind you of what the equation was. It was x H2 plus y O2 equals 1 H2O. And what we just did is we found that 1 H2 plus 0.5 O2 equals 1 H2O. So what we're going to do is we're going to multiply by a value that clears the fractions. So we need to clear the fractions by multiplying the equation by an appropriate value. And so since our number, this is 1/2, 0.5 is 1/2, let's multiply by 2. So I'm going to put a 2 times the entire equation, and so my balanced equation would be 2H2 plus, now this would be 1 O2 equals 2 H2Os. And now we have a balanced equation, and that would be my solution. Okay, so there you go. 2H2 plus 1O2 equals 2H2O. So that is solving a matrix, or solving a chemical equation via matrix method. So it's sort of a new technique. All right. If you, whenever this happens, if you ever get a fractional value, you have to do this. If you don't have a fraction, you don't have to do that, then your answer is fine. But if you get a fraction as a number of molecules, then you have to clear it in the way that I did. Okay, I will pause here.